Chapter 7, Arrays. In this chapter, we will revisit the idea of the data structure of an array. If we recall from our previous experience, an array is a data structure that holds many pieces of information under one variable name. So an array is an organized data structure which can hold multiple values of the same type. Those values are stored in adjacent memory locations. Unlike when we declare variables, they're sort of scattered throughout memory, but when we declare an array, those locations within the array are all adjacent to each other. Arrays are passed by reference automatically when passed as a parameter, meaning any changes made to the array in a function will directly be reflected within the array in memory, and we'll revisit that later on. When we declare an array, we declare array using the square brackets. Very similar to when we would declare an array in BASIC, and we would give it a size. We used parentheses in BASIC, but we will use the square brackets in C++, and most of the modern day languages do that. Here we can see an example of an array being declared. It has always a data type. In this case, we are declaring it to be of integer type. It has an identifier name, which is the variable name. Okay, in this case, tests. And then it is declared oftentimes with a size. And we'll see a little bit later on different ways to declare an array by not giving it size, but how we would need to do that. So, and then the size is inside of the square brackets, very similar to what we saw in BASIC. So if we look at tests in memory, the definition of our test, this is going to hold only integer values. You can see that I'm going to have 5 elements stored adjacent to each other in memory locations. So in terms of declaring the size, and so this is a little unique to the language itself. Named constants are commonly used as a size declarator. That's using a variable of constant type. If a variable will be used during the declaration of an array with size, then the variable must be of constant type. So in this example here, instead of using the 5 in the square brackets like in our previous example, which is valid, if I want to use a variable that represents the size, then the variable itself must be of constant type. And that is unique to this language. Not all languages require that. So take notice all uppercase like we normally would use in the form of declaring a variable of constant type, and that is placed in the brackets instead. So that is a valid declaration. It's just that it must be of constant type. This eases program maintenance when the size of the array needs to be changed. So that way I don't have to find every instance of the array within my program. I can change it directly. Arrays can be used with a regular constant integer when declaring it, which is what the previous example was in the previous slide. So both of these are acceptable ways of declaring an array. Now, none of these are stored with value in them at this time. So accessing array elements, each element in an array is assigned a unique subscript. We used the vocabulary of an index or an address. I will use all 3 words interchangeably, but a subscript would be the same reference as an index or an address. Remember, an element is the actual piece stored inside of the array. So here we can see our array tests. It's of size 5. But notice that the subscript starts at 0. That is not changed. Where we start at 0, the last element subscript is n-1. where n is the number of elements in the array. And so this one is of size 5. So therefore, it's going to be indexed from 0 to 4. So that has not changed and will not change from our previous experience. Remember, the element is the value stored within the array. So here inside of the array tests at index 1, we can see that if I retrieved that value, it was going to retrieve a 14 from its memory location, grabbing a copy of that 14 out of memory. If I want to access array elements can be used as regular variables. So here we can see an example of direct assignment where I am assigning in my array at location 0, I am assigning the number 79, again matching data types. I can see out what's stored at test at 0, so this is going to display 79 to the screen. It's going to grab a copy. Okay, it's not removing it from the array, it's grabbing a copy from the array, so there will still be a 79 in location 0. I can do direct assignment from the keyboard, so I can do a cin statement here, and this would assign whatever the user enters into array location 1. So let's say the user enters 50. From the keyboard, it's going to assign 50 directly to the array at location 1. I can overwrite or fill in. So here at index 4, it's going to take a copy of what's at 0. So we have 79. It's going to take a copy of what's at index 1, which is 50. It's going to add those two values together. And so it's going to then store it into the array at location 4, which is the 5th element in the array. So keep that in mind, that idea of that off by 1. So we can use it in the same way that we used our variables in all of our previous examples. Arrays must be accessed, though, by individual elements. So since tests is the variable that represents the array as a whole, okay, it represents the entire structure, I cannot see out the entire structure. I would have to take care of them each element at a time. I can only process each element at the time. I cannot look at the whole array as a whole and see out that array. I can't copy one array into another as a whole. So I would not be able to do, let's say I declared, let's see, test 1, which is an array equal to tests. That would also be illegal. I can't assign another array into a newly declared array. I actually have to copy them in one element at a time. Arrays retain values within a subscript unless overwritten. So each time we were taking out, for example, up in here, I was only taking a copy, which again is demonstrated down here in this statement. It is only pulling a copy out unless I would overwrite it through some form of direct assignment, whether that is a cin statement or an assignment statement. So here we can see an example of a program. We have an array called hours, okay, which is going to be declared of size 6. So somewhere in memory, I have an array of size 6 indexed from 0 to 5. And so they're going to get the hours for 5 different possibly employees or 5 different sets of information. These will assign directly into the corresponding locations of the array. Here then they ask to display the array. And so they are referencing each one individually. We'll see in a little bit how we can use a loop to do that same process. But here they're taking a copy out each time. So in this case, they entered 20, 12, 40, 30, 30, and 15, and it will spit that back out 20, 12, 40, 30, 30, 15 with what was stored in memory. And then we can see an example of what hours looked like in memory with those elements stored inside of the array. Accessing array contents. So we can access elements with either a constant or a literal subscript, so variable. Okay, so here they're using the array and extracting a copy stored at address 3. Address 3 is the fourth element of the array. So it will retrieve a copy and display it through the console. We can also use a variable that represents an integer. They can only be integers indexes. And so here this is going to print a copy of what is stored at index 5 within the array. And again, displaying it to the screen. So very much like what we did last year, just brackets instead of parentheses, but that anytime I want to access a piece of the array, I got to tell the system which piece do I want from the array using an address or a subscript along with the variable name in order to do that. Using a loop to step through an array. So the following code defines an array called numbers and assigns 99 to each element in the array. Not sure why you would do that, but this one's doing that. This guy's of size 5. So take notice we can use the constant as part of the looping structure, so I don't have to keep track of what the size of the array was. So that use of a variable is very important. It just makes it a lot easier for us to, keep in mind. And then that way, if the array needs to change in size for an updated program, I only have to change one instance of the size. I don't have to find every place that I use that 5 and make sure I update it correctly. And so here's a looping structure again with the idea that we're using the counting variable of the loop in order to access each location within the array. And this one is going to create an array of size 5. And it's going to store 99 into each location of the array by accessing each element of the array one at a time. Now, there is an issue with C++. It does not do any bounds checking. Basic at least did a little bit. When you use a value of an array subscript, it does not check to make sure that it is within the boundaries of the array. In other words, you can use subscripts that are beyond the bounds of the array. You're just going to get a lot of garbage. Okay, it's not going to tell you that you've worked outside of the boundaries of the array. This results in logic errors and unexpected results. So here we have an array of size 3, and they are going to process out to element 4, or out to address 4 and address 5, and actually 3, 4, and 5, and that's problematic because this one's only going to go from 0 to 2. And so it's going to fill it with garbage. It's not going to tell you, it's not going to break down, it's just going to overload the array. So here we can see the original array is only of size 3, yet it iterated 5 times. And so in essence, it overflows it. It just works outside. They don't actually exist as part of the array, so it tries to fill it. I just can't access them. So it does matter. I can get garbage if I try to access out of the boundaries, whether it's to copy it in or to take a copy from. Keep in mind the OffByOne errors. We had that last year because it is indexed from 0 to n-1 and not starting our counting at 0. Oftentimes we can be thrown off. Here counting starts at 1 and it goes to the size of the array. That causes logic errors because we're going to work ourselves outside of the boundaries of the array, and that's a problem.